本日はお忙しいところ、弊社ウェビナーにご参加いただき、誠にありがとうございます。SBG システムズのキョッキと申します。本日のウェビナーでは、完成広報システムの技術の紹介と、日本オフィスの設立による新たな取り組みについてご紹介いたします。技術説明部分に関しては、アジアパシフィックサポートチームのマネージャーであるニコラスが詳しく説明いたします。
Hello everyone, I'm Nicolas Michel in charge of the technical support in the APAC area, and it's very nice to do a webinar with you all and with Kiyoki.
進行中にご質問などございましたら、チャット欄へご記入ください。最後に Q&A セッションも設けておりますので、ぜひお気軽にご質問ください。それでは、本日のウェビナーについての流れをご紹介いたします。こちらのスライドをご覧ください。フランスとはちょっと時差が8時間があって、現地時間は現在朝6時であるため、CEO の千保からビデオメッセージをお預かりしております。まず簡単に SBG Systems にご紹介いたします。SBG Systems は2007年にフランスで設立された姿勢ナビゲーション技術に特化した企業です。現在日本を含めてグローバルに展開しており、社員数は120名以上です。その半分以上 R&D に所属する技術志向の会社です。まず私の方から今の業界動向と課題についてご説明いたします。どうして完成広報システムは今重要になっているかを整理してお伝えします。主な理由としては4つあります。1つ目としては自律走行やロボティクスの高度化です。最近では工場内の自動乾燥ロボットだけではなく、公道での自動運転の実証実験も各地で進んでおり、街中でテスト車両を見かける機会も増えてきました。また、災害対策や過疎地の物流を支える取り組みとして、無人飛行機による荷物の発送実証も広がっています。さらに近年では水中ドローンや AUV といった水中ロボットの活用も進んでおり、海洋調査、インフラ点検など多様な用途で自律化が進展しています。水中では GNSS が全く使えないため、安定したナビゲーション技術が欠かせません。このように自律システムの社会実装が加速する中で、求められるのは単なる位置情報の把握だけではありません。姿勢制御や自律判断に必要なナビゲーション技術全体の精度と安定性がより重要になってきています。そこで欠かせないのが完成広報です。2つ目の背景は点検や測量などセンチメートル級の精度が求められるようになってきたことです。日本では高精度測位を実現するためにシーラスと呼ばれる補強サービスを含め準定調衛星システム、導きの複数衛星が対応が進んでいます。これにより、建設、測量の現場では、従来よりも高い精度で位置情報を取得できるようになりました。こうした高精度の流れの中で、完成広報は GNSS が持つ精度を安定的に引き出す補完技術として、ますます重要になってはいます。3つ目の背景は、都市環境の複雑化です。大都市では再開発が進み、高層ビルや大型施設が増えています。こうした環境では、ロボットや車両が取得できるデータにノイズが入りやすく、センサー情報を安定して維持すること自体が難しくなります。これは GNSS だけの問題ではなく、周囲の構造物によってカメラやライダーの視界が遮られたり、複雑な動きが要求されたりすることなど、すべてのセンシングに影響が出ることが増えています。そのため、自律走行やロボットでは単一のセンサーでは足りず、安定した姿勢情報を軸に他のセンサーを補完できる完成広報の役割が大きくなっているというわけです。そして4つ目は、完成広報が高い応答性と安定性を持ち、複数センサーと組み合わせることで強力な自律システムを構築できるという点です。完成広報は加速度、 角速度を高い周波数で計測するため、外乱が多い環境でも滑らかに姿勢と動きを推定できます。また、GNSS やライダー、カメラと組み合わせることで、先ほどのような山間部、都市部、複雑なロボット環境でも安定したナビゲーションを維持することができます。つまり、完成工法は単独でも自己完結的な動作ができる上に、センサーフュージョンの中心軸としてシステム全体の信頼性を高める存在なのです。一方で、これまで主流だった GNSS による測位ですが、実は単独で使うといくつかの課題があります。次に、その GNSS の単独測位の課題についてご説明いたします。建物によるマルチパスやトンネルなどで GNSS を受信できないといった課題は皆様すでにご存知かと思います。それに加えて、最近ではニュースなどで太陽活動の影響について耳にする機会も増えているのではないでしょうか。また近年では不安定な国政情勢の影響もあって、ジャミングやスブーフィングといった意図的な妨害もリスクマネジメントの観点から無視できない存在になっています。ノルウェーでは毎年ジャマーテストが開催され、各企業が対策に取り組んでいます。ちなみに今年は SBG Systems もこのジャマーテストに参加しました。こうした完成工法の重要性や GNSS の課題を踏まえ、日本のお客様により近い形で活動することが重要だと判断しました。その結果として SBG Systems Japan を設立しました。それでは、オフィスの設立の理由やこれからの展望について、下のビデオメッセージをご覧ください。
Good afternoon, everyone. I'm Thibaut Bonnevie, co-founder and CEO of SBG Systems. SBG Systems has now turned 18 years old. We started in France with two friends out of university. We're now becoming a larger company with presence in countries in Europe, in the US, and in Asia. We're extremely happy today to announce the opening of our Japanese office. Japan is a very unique market with probably the most skilled engineers, the most demanding application we've seen worldwide, and we are extremely happy to be able to learn at your side, to challenge our technology and the technology we have developed so far. It's going to be a great journey in the next few years to partner with you, to learn from your experience and your application. SBG Systems today is focusing on delivering a very high accurate inertial navigation systems based on MEMS technology. We are willing to address a large number of markets, from marine sciences to land and aerospace segment. Japan is a very diverse market as well. All those activities, you have mastered them and developed them, and it's a great honor for us to be able to partner with such skilled customers. You've been able today to meet with some of our key team members, Kyoki and Nicola, and I hope you enjoy this event as much as we enjoy working with you on a day-to-day basis. I hope that we can meet maybe in the future in person in Japan, and I wish you all the best during this webinar.
Thank you, Thibaut. それでは、ここからは技術チームのニコラスにバトンタッチします。ニコラスから完成工法を支える SBG の技術力や強み、事例についてご紹介いただきます。Hello, Nico. I will hand over to you to introduce SBG's technical strengths and case studies.
Thank you very much, Kyoki. We will now dive into the INS technology. So what do we mean by INS technology? So for us, the INS will be the Inertial Navigation System, which is comprised of the IMU at the core, which includes accelerometers and gyroscopes, and sometimes magnetometers. But the core of the IMU is really those sensors, accelerometers and gyroscopes. On top of that, we will have our brain, the algorithm, that will be finely tuned depending on the application. And this algorithm will be complemented with aidings such as GNSS that will bring position, velocity, time, and heading, as well as some other specific aiding depending on the application. For instance, air data for airborne applications, odometer for land applications, or DVL for marine applications. And all this is fused with the algorithm to give us a more accurate and more reliable position, velocity, time, as well as computed roll, pitch, and heading, and eventually ship motion as well. So this INS will be, as mentioned, based on an IMU inside for inertial measurement unit. This IMU is using a MEMS technology. So this IMU relies on accelerations and rotation speed that we will input in our filter. And the advantage of MEMS technology, it's excellent performance over price ratio. And the MEMS technology started small, but improved a lot over the years. And we can go from the technology you have in your smartphone to the technology we have in an Apogee sensor, which is the best of MEMS technology currently we have. So all this range of IMU can give different performance and is still extremely efficient in terms of perf over price ratio. So the INS technology relies, as I say, heavily on the IMU, and this means we need to have good, accurate IMU. Now, what does this mean? So this means that we want to have a low noise, low bias, and a very good stability over time. So to have that, we can characterize this with what we call an Allen variance. This is how we characterize different sensors, such as the accelerometers and gyroscopes, to identify all the different kind of noises that are on the signal. And on these noises, we can identify two different kind of noises. Noises that are predictable or repeatable, and noises that are unpredictable or they're not really repeatable from start to start. So the predictable noises are typically compensated in factory. So this will be the bias you have in temperature, for instance. And that's why the calibration in temperature is very important. And in addition to that, we also have unpredictable noises. Those noises cannot be calibrated at factory, but that is why we have the Kalman filter in real time that will warm up and estimate those biases. And this is very important if we want to have optimal performance. So this will give us a more accurate IMU based on both the factory calibration and our real use of the Kalman filter that will keep estimating those errors in real time. Now we'll see different improvements, like latest improvement and then future coming improvements. So among the latest improvements, we improved a lot the HEAV. There was a significant accuracy improvement, basically on the HEAV to get better performance, especially on the ellipse sensor. This comes mostly with algorithm improvements with the latest firmwares. So this really helps for some application that requires in marine the ship, like the HEAV data, to actually be more stable and more accurate. We have another improvement is we add GNSS configuration improvement. So this is very important because in some cases you prefer to use specific constellations. We like to keep it simple for the configuration, but we don't want it to be a full black box either. So we try to minimize the settings to make it very easy to use, but still have control about necessary features. So we recently added this GNSS configuration that can help in specific cases. We also have a very nice improvement, which is our FFT tool for fast Fourier transform. So this tool is especially useful if you have an application with vibrations. Typically, what we could have on a UAV, for instance, or a helicopter. In this case, sometimes you have a lot of vibrations. And in that case, you want to identify which vibrations are problematic in order to correctly compensate them and correctly design the damping system for the MEMS. So we, of course, have MEMS technology that are already quite vibration resilient and shock resilient, but in some cases, the vibration can be very, very harsh, and we recommend to have a damping system. This is where the tool comes here, and you can simply record the data and monitor it later, or monitor in real time the vibration data. Another big focus we had lately was on fighting interferences. This comes with some jamming and spoofing indicators. So we have those flags that came here to indicate if we suspect interferences coming from jamming or spoofing. We also did some tests to validate different CRPA antennas to ensure that we can use these antennas to fight better jamming. And that can be used in, well, typically military applications, but also can be used in other applications as well. Another big improvement we have is in the form of velocity aiding. So as I mentioned at start, you can connect the system to different aiding, such as DVL, odometer, air data speed sensor. But we also now have a generic velocity aiding. This aims to improve a lot the dead reckoning performance. So if you can have aiding, any kind of aiding that can give a velocity in 1, 2, or 3 dimensions, then now you can convert this aiding into a generic format that we'll use here, I mean, an SBG COM format that we'll use here to read and use this data into the navigation algorithm. This can really bring significant performance boost depending on your application. So if you expect outages, then you may be interested by that feature. All right, now we have also some coming improvements that will arrive soon in future. One of them being the external magnetometers. So we have some units that already include magnetometers, such as the Ellipse series. But on the high performance INSs, we do not have magnetometers internally, but now we will be able to have the external magnetometers input, which can be very useful to maintain a good heading if you cannot have a GNSS signal. Typical example would be in underwater application, for instance. Of course, these magnetometers can be calibrated, and we provide the calibration algorithm if you are using our own Ellipse or Pulse 20, for instance, as external magnetometers. Next, we do have the new air data input and a UAV fixed wings motion profile, and this aims to improve dead reckoning performance for the air application. So in case you are, for instance, on a UAV that expects to have GNSS denied environment, this will really help to improve performance in this situation, especially in the position where you want to maintain a higher accuracy level on the position. On this, we will have an example on the a bit later on the demonstration log. Right, so another improvement that will be coming is that we will help to improve the initialization in single antenna, especially useful for UAV if you need to have your heading in advance and initialize a full system before takeoff. So that will be done by injecting your own heading into the INS. In a lot of setups, we can use dual antenna, but in some cases, there is no space, or it's not convenient to have dual antenna. And in this situation, we have to rely on single antenna instead. So we are very aware that initialization is still important in this case, even sometime before starting up the system and before taking off. Another key improvement, this time on vibration again, will be coming in the form of integrated dampers on the system. So you would have the option to directly get the IMU with integrated dampers to be more efficient in terms of very harsh vibrating environments. As we could identify the best system to damp your IMU, especially designed for these small compact IMU we have at SBG Systems. This can be very handy in special applications. I'm thinking about typically UAVs, where you can have a lot of vibrations, but it's also very useful for any kind of other applications, of course. And we finally have coming improvement in the form of gyro compass. So this MEMS gyro compass will allow you to have heading in a compact format without GNSS or magnetometers. So this is extremely helpful in case you need to keep a good heading in those GNSS denied environments, and if you cannot have magnetometers due to different interferences or disturbance, this gyro compass will be very, very helpful for these applications and give you an accurate heading even with no signal at all. So this is a new coming IMU we are very proud of that will really help to unlock new markets for us. All right, now we can have a little comparison between IMU integrated in GNSS receivers versus INS systems. So in some cases, you may find GNSS receivers with integrated IMU inside, and you may wonder what's the difference with an INS? Well, typically, GNSS with IMU would be more GNSS-centric, means you focus on the GNSS algorithm that will enhanced by the IMU, while on an INS, such as the one we propose, we are typically IMU-centric. We focus on the IMU first, and then this will be enhanced by the GNSS that will keep correcting the drift of the IMU. So typically, GNSS with integrated IMU will be smaller. The idea is to be cheap and cost-effective, but this might impact performance. If you have a very small IMU, sometimes you might not reach a performance of bigger IMUs, which bigger sensitive elements that would be more stable and more accurate. Other key elements to take into account is, as I mentioned before, the IMU calibration. On our system with IMU-focused development, we really focus on having the best possible IMU, which comes with a calibration to remove all biases, such as scale factors, the temperature biases, the alignment, etc. So why would you choose one over the other? Well, typically, it's a bit of a trade-off between performance and costs. So if you expect a very easy environment with not a strong need for accuracy, then you may prefer the GNSS with integrated IMU. Now, if you expect a harsh environment, or you require a high accuracy on roll and pitch, for instance, then this is where you would probably prefer to go toward an INS. So, for instance, on this photo, on this image you can see here, you would typically have like a tunnel with a very harsh environment, a lot of buildings around, which would really make the GNSS struggle a bit more. So for very short outages, the GNSS with integrated IMU might be sufficient. Now, if you have longer GNSS outages, then you may prefer to switch for an INS. So it really depends on the environment that you're looking for and the performance you're looking for. Now we'll focus on some key strengths of SBG systems. So one of the key strengths we have is the very fine-tuned algorithm. This comes with a very important element, which is a sensor bias estimation, such as on the gyroscopes and the accelerometers. If you have a static system, you may still see some motion because of biases. And the algorithm will try to detect those biases and correct them, and you can have access to the corrected output directly. Another element is a motion profile. So typically a Kalman filter, the internal algorithm, will be quite versatile, but ideally should be calibrated, should be tuned for a specific application. So we have selected an easy way to configure through motion profiles. So for instance, we have marine, we have train, we have automotive, we have airplane, we have different motion profiles that are tuned for a specific application. And this helps to re-optimize performance depending on the anticipated dynamic of the system and vibration level and very specific constraints that we can have in one application or the other. Now we also have one of the key strengths is that we have a software like Inertial that will allow to simulate real-time condition. This can also be done directly with the unit. If you have the INS, you can do a test on your own. But we also have the option to simulate testing and to try different settings and different GNSS outages on a specific log that you would have recorded. As I mentioned before, we also like to focus on ease of configuration, which is why we come with motion profiles. We also try to make it very easy and have a very easy setup to visualize your setting. So when you configure step-by-step all your settings, you will have at the end a little 3D tool to make sure you didn't do any mistake. It's extremely useful because when you are trying to configure a system, sometimes you forget a sign or you have an error, a typo in the lever arms. This little tool will help you to check if everything is all right. In addition, we also have a tool to re-estimate the GNSS lever arms. So if you are not sure of your measurement, you have the option to try a real-time calibration, or with Inertial, we have also calibration tool. And it's also a tool that is available independently from Inertial. And this is all to make sure that the configuration is optimized. Another key strength that we have is that we are maintenance-free. So the factory calibration is done on every unit, and then is sufficient on these units. So we have thousands of units on the field, and these units never came back for recalibration, and they keep being used. So we are very happy to propose recalibration should you need it, but most of the time you would not need it. You would just have the unit working on the field directly. So that's also a very good element to have, that when the system is installed, then there is no need to send it back to factory after a few years. You can keep using it and not worry about this. We also have one of the key elements we provide is technical support. So this comes in different forms, such as assistance remotely or on-site. We can directly come and help to make sure the system is operational and works perfectly. We, of course, can do that in full confidentiality, should that be needed. We have several of our partners are military, and of course, in this area, it's extremely common to have a lot of confidentiality. So this is also it's very usual for us. We provide also some quick start or trainings to make sure that when you have a unit, you know how it works and you get started quickly. The objective is that you would start using the unit and you would directly use it in the best conditions and know exactly which status means which indication. And then we can give advice. So if you have a setup, you are wondering what would be the best product or what would be the best way to use a product, then we would help based on our experience. Then we do have a very modular system. So the idea is that we have the same protocol for all units. So if you start with an ellipse and later you realize you need a boost in accuracy, you can very easily switch for an Equinox, a higher end INS, and still use the same protocol and same messages. So it makes it a bit easier in terms of interfacing with the unit. We can also use Inertial with any IMUs. So should you have your own IMU already and GNSS receiver, then you can directly use that with Inertial, thanks to our generic communication protocol. So we are very open and we don't want to restrict you in any way. And we keep adding new features, sometime on demand. If we have high demand for specific features, we are very happy to accommodate and to work toward this direction. We like to do partnerships as well. So that's something we are quite familiar with as well. All right. Now, finally, we'll discuss about the quality. So we are at SBG Systems very proud to have high quality products. The objective here is that you should trust our specification. And we want to make sure that everything on paper is what you get on site. So that's why we have very good calibration. So your product doesn't simply work in an office at 23 degrees Celsius, but also works in winter, in summer, outside, in all conditions. And if you have any doubt, we like to do tests with you. So if you have a specific application in mind and you are hesitating, then we would gladly come and help you to test our product directly. We think the best way to trust the product is also to directly see the product. So we have also, so on the IMU part, we are very focused on the quality of the IMU. And this is during component selection, where we have a very harsh test when we select and design the IMU. We would do shock vibration test, aging test to make sure that the stability of the product is ensured all on the product life. And this is very, very important. And as well as when every product is manufactured, they will pass a series of tests to make sure this product is valid and will work. So every product comes with a factory calibration and comes with their specific calibration report that will show all the bias and gain, non-linearity, cross-axis and misalignment, and gyro-G effect that have been corrected by the calibration. So that is also a very important aspect of the IMU, is to make sure that the IMU you receive is a high-quality IMU that will perform as we intend. All right. Now I will have three quick examples to show you. So I will show different examples of tests. One on land showing road testing. One on air using the air data, which is very useful to try GNSS denied environments. And finally, one marine in collaboration with HSD, Hydro System Development, and JUMSAT, in very extreme conditions in Tokyo, where you can see we are on a boat on a river under a bridge. So this is very difficult condition. All right. So let me switch my screen to present. Okay, so now you can see here a test that we did in France next to the headquarters. So this is a test with the Equinox Micro on a car. You can see the headquarters are here. This is SBG Systems headquarters, so in this case, I use Inertial to present the real-time and post-processed result. So we did a little drive in the city, and we just drive around in the city, in the forest environment, so we test different environments. What's interesting, at some point, we couldn't go in a car park. You can see in the case here, the GNSS is completely lost. The GNSS is a yellow trajectory here. And what we see here is a real-time trajectory from the Equinox Micro. So we were driving in the car park, and the position, even without any GNSS, was still estimated and provided here, with some degree of drift, obviously, as we will be slowly drifting without any GNSS receiver. And with Inertial as post-processing software, we can correct the drift, which is represented by small inaccuracies here. So in real time, we could have a few meters of offset on the position as we were driving in this car park. And with Inertial, we can properly correct it, so we can have a real, more accurate estimated position. So this is a very good example of a driving test where we have a GNSS outage and how we can compare real-time and post-processing. Right, now I can also show you an example of airborne data. So this is a flight test that we made in France. This is the north of France here. And what's very interesting in this case is as we fly very far away, we can use a VBS as we use several base stations. So in this case, you can see that we have a lot of base stations available in Europe. And Inertial will automatically select all the necessary base stations around the trajectory to create a VBS area. And this is very useful when you decide to drive very far away and go a bit further. This is, and the base stations are available very easily. You can see which base stations are available in your specific area if you connect to my SBG. In this case, you can see there is a very dense network of base stations in Japan, and it's very easy to be in a range of a base station. Now, what we can see here is this test there will be, sorry about this. Okay. So in this test here, we can see we were flying around and going north and then coming back. And what's interesting is that we can eventually simulate GNSS outage. To simulate the outage, I can simply select an area and say, oh, on this path here, I will just reject the GPS. Say, okay, we cut GPS and true heading. So now on this area, there is no more GNSS. It's GNSS, but we tell the algorithm to reject it. Then I can very easily do a reprocessing and eventually re-estimate lever arms if I want to. It's optional. And as I don't have RTK, it will not be extremely accurate, but with post-processing, I can do a more accurate one. So in real time, we do a reprocessing. So here in this case, we run the algorithm as it would be doing in real time, except now we created an outage. So on this area, then we cut GNSS, and we can see it drift. Okay, we cannot see much, but it did drift a little bit. Where is it? Okay, so actually, we didn't drift much in this case. And we re-estimated lever arms, but it's not extremely accurate because we do not have RTK in this case. So here, we can see here, we had the drift. So the unit was indeed in dead reckoning performance with no GNSS and drifted. Then when the outage stopped at the end here, the unit used GNSS again. And we can very easily monitor, okay, we drifted by so many meters, for instance. So this tool is extremely useful to simulate different conditions. Now I have a final example to show. This is Tokyo, and this will be typically what we can see when we have GNSS outages, or not full outages, but very harsh conditions. So in this case, I can show the GNSS alone, and you can see the GNSS alone is quite terrible. We were on a ship, and when the ship goes under a road here, in between high buildings, the GPS is struggling a lot to maintain a position. And as we are under the water, under the highway, and on the water, it only becomes good again when we get in open sky. I mean, a little bit more open sky. And now, if we use, in this case, a 9S NDL, then we can have a way better trajectory. So we can remove GPS, and now we have a way more accurate trajectory compared to what we had before. So this is the point of the INS, and also which can be further improved by Inertial. So it's just some quick examples. We will not dive into the details here, but of course, if you are interested, don't hesitate to contact us. We will show a little bit more and go a bit more into the details of this. All right. All right. So this is the result of this test I showed, where we were under the bridges, and at the end we have a very nice 3D display, the point cloud display that is very impressive, actually, considering the very harsh conditions we had. All right. Now, if you want to know more, you can contact us, or you can directly access it on our website. Especially on our website, there is a part in the test report section where you can directly see a lot of test results. If you have a specific application in mind, it's probably already there. Thank you very much for your attention, and I will give back the lead to Kiyoki.
Thank you, Nicholas. たくさんの強みをご紹介いただきましたが、個人的に特に注目しているのはファームウェアの無償アップグレードです。最新のセンサーフュージョンの技術の進化をお客様にスムーズに届けられるのが嬉しいポイントじゃないかなと思います。これらの技術を活かして日本での取り組みについてご紹介いたします。まず、日本のお客様への製品提供やサポートについてです。日本では陸と空の分野で強みのある代理店を新たに整備し、お客様の領域に詳しいパートナーと連携できる体制を作りました。これにより、それぞれの分野のお客様には、自分たちのニーズをよく理解している代理店様が対応するという安心感を提供できます。従来から製品とサポートを提供してきた分野については、これまで通り代理店様経由で対応していますので、既存のお客様もご安心していただけるんじゃないかなと思います。代理店様の方で一時的な問い合わせに対応しますが、日本オフィスも必要に応じてバックアップとしてサポートします。代理店様と情報を共有しているため、お客様の方から直接私もしくは日本オフィスにご連絡いただいた場合でもスムーズにご対応できます。その対応内容は日本オフィスからも代理店様にも共有いたしますので、今後のサポートにも活かされることができると思います。次に、開発や技術協力についてです。開発や R&D、技術協力は長期的な取り組みで、即時の販売利益に直結しないことが多いです。こうした案件は日本オフィスが直接関わることで、情報をスムーズに共有し、効率的に進むことができます。その結果、代理店様の方は販売やサポートに集中でき、お互いの役割を効果的に分担することができます。もちろん、代理店様のご意向を尊重しつつ、連携して進めていく体制も整えています。また、今年は企業様向けにワークショップを実施いたしました。 こうした活動を通じて、お客様の日常業務の課題をより具体的にヒアリングできて、弊社の製品の新しい機能も迅速に取り入れていただくことができました。今後も企業、学生向けのワークショップやアカデミックのイベントを積極的に開催し、日本のお客様と技術を共有するとともに、共同開発や知識の蓄積を進めていきたいと考えております。完成広報技術の普及活動の一環として、今後、スポンサーシップや協賛も行っていく予定です。学生向けの自立制御や自立走行のプロジェクトを支援する予定でして、プロジェクトの内容をご連絡いただければ、場合によって無償で機材を提供できることもあります。実際、EU やオーストラリアでは、学生フォーミュラ大会に参加するチームへの支援実績があります。日本でもこれから同じような取り組みを始め、学生の自立走行技術の学びやプロジェクトを積極的にサポートしていこうと思っております。こうした活動を通じて得たお客様からのフィードバックは R&D チームに共有し、製品の新しい機能やアルゴリズムのさらなる進化に反映させていきたいと思います。これまでにも日本のお客様のご要望のもとに新しい機能を追加されました。今後もお客様の声を取り入れながら製品の性能の向上や創生性の向上を進めていきたいと考えてはいます。また、技術面では日本語での発信を強化していきたいと思っています。お客様にとって分かりやすい形で技術情報を提供していくことによって、日本市場に合わせた内容を配信することで、お客様がより具体的な情報を、自分たちにとって必要な情報を理解しやすいんじゃないかなと期待しております。こうした取り組みを通じて、今後もお客様にとって役立つ情報を継続的に提供していきたいと考えております。さて、本日、このウェビナーにご参加していただいた皆様に向けての特典のご案内になります。感謝の気持ちを込めて、私たちの製品を実際に体験していただける機会をご提供したいと考えております。特典の内容としては、デモ機の2週間の無償のトライアル、アド処理ソフトウェア、機内社の2週間無償ライセンス、そして立ち上げサポートをご提供いたします。これにより、製品をスムーズにご利用いただけるようにサポートいたします。ぜひ、この機会に私たちの製品を試していただき、その機能や効果を実感していただければと思います。ご興味がある方は、後ほどメールでもどうぞお気軽にご連絡ください。少し予定より時間が早く終わりましたけれども、もし皆様から何かご質問がありましたら、ぜひチャット欄にご記入していただいて、Q&A のセッションに移していきたいと思っております。すでにご質問いただいている方もいらっしゃいます。ご質問ありがとうございます。ちょっと内容を、はい。なるほど。ご質問内容としては、振動の実際のモニタリングの機能について興味があるんですけれども、実際どういうところで必要になるかというご質問になります。この質問に関しては、ニコラスに直接回答していただいた方がいいかと思います。はい、ニコラス。We have received one question about the vibration. He says that the vibration analysis seems interesting, but why it is necessary and what's the benefits when they can know the vibration?
Right. So yes, vibrations can be a problem, especially if they are too strong. And the vibration analysis, the new FFT tool that we have, is very, very useful to identify specific vibrations, especially the one with the highest amplitude. That's the one you will probably want to damp. So in order to properly find and design your damping system, then it's actually beneficial to know which frequency you want to attenuate. And that is where this tool comes in. This tool is very useful if you can really identify the problematic vibrations you have.
確かに、今まで、実際システムの中に投稿していくときには、振動によって、何かのノイズがあったりすること話がよく聞きますけれども、結局、どの周波数の振動なのか、どういうところで共振を起こしているかっていうのはなかなか把握することが難しくて、企業さんによっては、新たにそこで他のその振動を計測できる加速度センサーを出しては、また取り付けてはいるんですけれども、それだけでもなかなかその場所っていう振動が分かりにくいというところがありますので、IMU、弊社のその管制広報センサーの中の IMU で振動モニタリングができるっていうところは、一つ使い方としては考えられるんじゃないかなと思います。はい。次ごいただいた質問としては、ユーザーからの問い合わせ情報を見たり、情報交換できるユーザーフォーラムありますか？はい。ご質問ありがとうございます。実際こちらの方なんですけれども、特定の技術のテーマに関してのそのユーザーフォーラムがありますけれども、一般的な公開している、ユーザー情報を交換できるユーザーフォーラムは今のところ特に用意してはいないんですね。ただ、そういうニーズがあるのであれば、ちょっと弊社のマーケティングのチームにも、今後どういう形で対応できるかを考えていきたいと思っております。はい。次のご質問もいただきました。そうですね。ちょっと待ってくださいね。ヘリのまた次のご質問なんですけれども、ありがとうございます。ヘリの振動も耐えることができるでしたが、ヘリでは通常、サインバイブレーション、ランダムバイブレーションだけじゃなく、サイダウンランドレーションしか求められます。なるほど。Nicholas, I think this question is also, it's better to ask you to reply it. The question is about the helicopter vibration, because now always, because besides the sine vibration and random vibration, there are also like the site unrandom vibration test may also be necessary. Do you think for us it's necessary to do something for it?
Eventually, we have the tools in factory where we can do vibration tests on our IMU. So if you do have the vibration profiles already of your application, and you can communicate that to us, we can do some tests on our side to make sure the impact before going actually on test. So that is a possibility, yes.
場合によっては、弊社の本社の方でテストをさせていただいて、ご連絡差し上げるということが可能っていう回答になりますね。Thank you, Nico. はい、次のご質問ですね。はい、Nicholas, it's another question for you. Is the built-in GNSS receiver compatible with all GNSS satellites? Also, could you please provide information on the supported frequencies?
You mean, sorry, the frequency for the GNSS receiver?
Yeah, like L1, L2, L5, L6.
Yes, that's right.
That's right.
Yep,
yeah.
Absolutely. This is information you can directly find on our support center. And that's why I wanted to point out that we can already have a lot of information. So if you have any questions on a specific application, of course, contact us. The technical support will be glad to answer. For specific supported frequency, yes, we support L1, L2, and E5 for Galileo. This information is available on our support center. So if you go to support.sbg-system.com, you can find that. Depending on the product you're looking for. But typically, yes, we support multi-constellation, GPS, GLONASS, Galileo, Baidu, QZSS. We support the L1, L2, and E5 frequencies.
はい。今のニコラスの回答の補足として、ちょっと私の方からも日本語で案内させていただきたいと思いますけれども、先ほどニコラスの説明にあったように、弊社の方で SBG サポートセンターっていうサポート用のウェブサイトを用意しておりまして、で、このサイトには製品ごとも分けてご紹介があります。それぞれの例えば今対応している GNS 受信機の仕様に関しては、製品ごとに若干違っていまして、弊社の方で内蔵している GNS 受信機は主に U-BLOX の製品とセプテントリオになります。エリプスとエキノックスマイクロは U-BLOX の受信機になっていて、で、そこに関しての詳細は、パフォーマンススペシフィケーションの中に、ここに、ごめんなさい。ちょっと待ってくださいね。ちょうど待っちゃいました。ごめんなさい。ですね。簡単なところをお見せした方がいいですね。製品ごとになっておりまして、例えばエキノックスマイクロも中に、
If you is the frequency, is it? Yes, it's here. Yeah.
Here, right?
Yeah.
あ、
And it's
すみま
just
せん。
here. Yep.
はい。一つの、サンプルとしては、こういうふうに、GNSS レシーバーの、仕様としては、確認していただくことになります。その他にも、実はこのウェブサイトの中に結構いろんな情報が詰まってありまして、ハードウェアのマニュアルだけではなくて、How to というのもありますし、あとは実際、例えば外部の受信機を入れるときの対応の仕方だったりとか、あとは、そうですね、日本では結構エントリップ、RTK 対応のご質問もよくいただきますので、エントリップサーバーは製品がハードウェアの中に内蔵していますので、その時にどういうふうに設定していくかっていう説明もここでご確認していただきます。あとは、先ほどニコラスの方からご説明させていただいたように、空、陸、あとは海というそれぞれのアプリケーションに対しては、実際、オペレーションの、オペレーションのマニュアルとしてもご案内しておりますので、もしご都合がよかったらぜひ一度ご覧になっていただければと思います。はい。次のご質問もいただきました。
If I can add, if I can add something. Yes, if you want to use your own GNSS receiver, you can. It's compatible with specific binary protocols, but also with generic NMEA protocol as well. So it's possible to use an integrated GNSS receiver or choose another one eventually.
はい、ありがとうございます。ありがとうございます。次のご質問もいただきました。すべてのハードウェアに共通しているプロトコールがあるんですけれども、ファームウェアを更新することによって、プロトコールの変更があるかどうかというご質問ですね。はい。Nicholas, the next question is about the firmware upgrades. So when the firmware is upgraded, are there any changes to the protocol?
No, we keep compatibility. So each time you upgrade the firmware, you will still be able to use the messages with the unit.
はい、Thank you. プロトコールに関しても基本アップグレードすることによっての影響は特に受けないということを理解していただければと思います。 時には新しい機能を追加することによって新しいメッセージが出てくるところがありますけれども、はい。そういう時には新しい、性能の、出力を使う時には、そこを合わせてご確認いただければと思います。次のご質問もいただきました。ありがとうございます。The next question is how to migrate invested data into laptop. Is there a specific connector?
To send data to a laptop?
Yes.
So you can have it in real time by serial port like RS232 or RS422. Then you will probably want to use a converter, a USB to UART converter to convert into USB port, unless your laptop still have those serial connectors. Or you can also use Ethernet, which is very convenient. So on the HPI product, you can use Ethernet as well. And eventually, if you have a recording, then you can use our software, such as SBG Center or Inertial, to read the recording that you previously acquired.
製品によって実際の通信インターフェースはいくつかが用意しておりまして、例えば先ほどニコラスの方からご説明させていただいたようなシリアル通信の場合ですと、弊社の方でUSB が変換できるケーブルも用意しております。そのために実際センサーとパソコンの接続はセンサー側の方がフィッシャーコネクタでして、パソコン側は USB ケーブルというふうにつないでいただければ、SBG センターっていうアプリケーション、もしくは実際のバイナリーデータとかをパソコンの方に取り入れていただくことができるようになります。で、一方で、実際のイーサネット通信を用意しているハードウェアもありまして、その場合ですと、もう本当にイーサでそのまま通信できるようになりますので、比較的に簡単にパソコンの中にデータを取り入れることができるんじゃないかなと思います。はい。説明になりましたでしょうか。ありがとうございます。それでは。はい。次のご質問もいただきました。ありがとうございます。実際の取り付けに関してはかなり厳しいと聞いてはいますけれども、それはどうしてなのでしょうかっていうご質問ですね。はい。ニコラス。The next question is also sometimes I want to talk with you because in Japan, lots of the times, especially for just the test, it's very difficult to ask our customers to screw the sensors unit with a very fixed condition. So what's the risk if we just use the tape to fix the sensor and the antenna to their applications?
Right. So it is possible to use tape only if it is not a performance test and you want to test connectivity and general functionality. But there is a risk to be suboptimal and to not be within specifications if you do not have a very, very good installation. There are two aspects. The first one is to have a rigidly mounted INS to the antenna, in a sense that if the antenna moves, and because we have very accurate sensor, then if even a small misalignment and a small difference in misalignment may have an impact, especially with longer lever arms. And this could cause a problem. So this is the first aspect. Second aspect is that if you may have misalignment, but you may also have small vibrations or shock that may actually impact the unit. So we would really recommend to have a rigidly screwed installation as much as possible. especially if you really want to reach the full performance of the unit.
やはりGNSS の信号を一番最初使ってセンサーのバイアスの評価をやっているところもプロセスもありますので、アンテナと同じその相対距離は常に一定であることを守っていただくことが必要になるかなということですね。はい。次のご質問もいただきました。ありがとうございます。取得した姿勢データを PC に準リアルタイムでテキスト形式で保存できますか？はい。こちらのご質問は私の方から回答させていただきたいと思います。取得した姿勢データは、準リアルタイムではなく、リアルタイムで、シムレスでパソコンの中に取り入れることができるようになってはいます。で、形式としては、実際、逆にお客様の方でどういう形で、どういうフォーマットのデータが必要になるかっていうのは設定していただくことができるようになります。例えば、バイナリ形式、もしくは N メガ形式という形でできるようになります。また、実際、自立走行とか自立運転の時には、パソコンではなく、実際のそのコントロールのメインの、コントローラーの部分に直接データを送って、で、そこから操作に使っていただくっていうこともできるようになってはいます。もし必要であれば、また後ほど具体的なその設定のところにご説明することもできますので、その時また個別に案内させていただければと思います。はい。ありがとうございます。また次のご質問いただきました。How to combine this product and original product?
I'm not sure to understand.
すいません。こちらのオリジンプロダクトっていうのは、どのように理解すればよろしいかっていうことでしょうか。チャット欄にご記入いただければと思います。ちょっとそのご回答いただくまでには次のご質問を対応させていただきたいと思います。今度のご質問はかなり単刀直入なご質問なんですけれども、通常のリードタイムどれくらいなのかっていうご質問なんですけれども、SBG の場合ですと、通常の製品であれば、だいたい2週間ぐらい、工場の方からご出荷させていただくようにはなってはいます。もちろん、時期によっては、若干、遅れたり、もしくは、ボリュームによってはちょっと調整させていただくことがあるかと思いますけれども、基本2週間以内で出荷することが、今のところはほとんどではありますね。はい。ありがとうございます。はい。ちょっとまだ時間がありますので、もしまだ何かご質問がありましたら、はい、チャット欄にご記入ください。Nicholas, do you think it's possible to do a very simply demo to show what kind of output that we can set in by using our Ellipse or Equinox Micro?
Yes, give me a moment. I don't have a unit connected.
Sorry for this request.
Okay. Oh, sorry, I forgot to share my screen. Hello. Okay. So here we have, for instance, an offsite unit which is connected, but our GPS position is a bit inaccurate because we are just by the window of the office. You can see, so the unit is not initialized, and we can interface this unit with different inputs, but then we have the outputs that are here. So all the data here is a SBG eCom protocol, which is available on serial or Ethernet as well. And we have the internal data logger that can log everything as well. So we can record internally, or we can output SBG eCom, so our proprietary format, or we can output NMEA data, which is fused data or non-fused, only GNSS. And different other communication protocols are available as well. Does this answer the question?
Yes. Thank you very much.
Okay. And then, as mentioned before, you can actually add various inputs, such as magnetometers or generic velocity, DVL in this case. This will depend on the motion profile. So if I select, currently I have a marine motion profile, so I can select every lever arm. So in this case, I didn't select anything, but I can put the antenna a little bit higher, for instance, and just enter every configuration as judged necessary here. And then, of course, if we are on another vehicle, then you would have a slightly different display. But the idea is the same here. You would have this 3D display where you can show, just control that everything is as it looks. And then we have different configurations, such as the serial, the Ethernet. So currently I'm broadcasting, but I can send to a specific IP if I want, and I can send to up to 5 different specific IPs if I want to send data to a specific equipment, for instance. So that is very easy to configure. And so as we said, we can record everything as well and send data or record data internally. And we can do synchronization with PPS, pulse synchronization, or NTP or PTP time protocol as well. So that's a lot of different options. And if you want to know a bit more about this, we can organize a demonstration, a specific meeting to just discuss this a bit more in detail for a specific application.
Thank you, Nicholas.
I would like to add one thing. I'm sorry. If all the data you have here, or each one of those messages that you can output to different frequencies, you have the full detail. If you go to our documentation here, you have the SBG eCom library. So in this section, you can go in Oxygen documentation, and you can select any messages that we output. So for instance, if I want to see Euler, what is inside EKF Euler, I have roll, pitch, and yaw, and the accuracy and the solution status, etc. I know precisely what are the data that are on, for instance, in this case, UKF Euler. So if I enable this message, I know exactly what I will get in the online documentation. Okay, so yeah, if you have any other question, don't hesitate.
Thank you, Nico. ちょっと時間はまだ早いんですけれども、もしまた後ほど何かご質問がありましたら、 いつでもご連絡を差し上げて連絡をしていただければと思います。Nicholas,
Yes.
could you please stop the screen, share screen?
Oh, sorry. Okay.
Thank you.
All right.
I want to show here. Okay. こちらに、私のメールアドレスとニコラスのメールアドレスも、記載いたしましたので、何かご質問がありましたらいつでもご連絡いただければと思います。はい、少し早くなりましたけれども、ここまで日本オフィスの取り組みと、製品、技術についてお話をさせていただきました。日本では私たちの活動が少しでも伝わっていれば嬉しいです。今後もお客様との連携を深め、より良い製品とサービスを届けるように取り組んでいきたいと思っていますので、引き続きよろしくお願いいたします。本日はお忙しい中お時間いただきまして誠にありがとうございました。今後とも SBG システムはよろしくお願いします。失礼いたします。
Thank you very much.